Okay, so number 10 has multiple parts, and here's the problem. And this is how I recommend that you go around solving it. Okay, and the way I recommend doing this is to create a table. Okay, and make these your headings. Okay, and so for every single resistor in your picture, you must enter a value. So these are basically 1, 2, 3, 4, 5, 6. Okay, so I have 6 resistors, and I'm just going to label them R1, R2, R3. They're already labeled for me through 6. And I also know their values because they're given here. So it's 2, 3, 7.55. Look with that. 10, 2, and 5. Whoops. Okay, so this is what you need to do. By setting up this table, what you have done is you've made a variable or a table entry for every single voltage, and you've made a variable or table entry for every single current. And you've also basically made a relationship, V equals IR, associated for every resistor, because that's true. Delta V equals I times R. Okay, if I know any two values on a row, not counting the resistor number, obviously, any two values, I can do delta V equals IR to get the third value. Okay, so now I have these 6 unknown voltages, 6 unknown currents. Great. Okay, but now this is where I need to start reducing them, doing the resistors in series and reducing in parallel equivalent voltages. Okay, because okay, R1 and R2 are clearly in parallel. R4, R5, and R6 are also clearly in parallel. So I need to reduce those before I can continue on. Remember, step 1 was to make variables, so that's what this table is. I made variables. Okay. Step 2 is to reduce the series in parallel. Okay. So R1 and R2, I'm going to reduce. Okay. And I'm going to label it R12 because that's the way I reduced it. Okay, R3, nothing happened, so it's still here. And then R4, 5, and 6 need to get reduced as well. So that's R4, 5, 6. Okay? And they're all connected to this 12-volt battery. I'm going to ignore the switch since we don't really talk about it. Okay, so that's what I need to do. Realize that R1 and R2 are in parallel, do an equivalent resistance. R4, R5, and R6 are in parallel, do an equivalent resistance. So I basically have now made 2 new resistors, okay? And those 2 new resistors need their own table entries. So I'm going to call this R12. It has a equivalent resistance that I'll need to calculate. And R456 also has an equivalent resistance that I need to calculate. But I can calculate them, okay? The R12 is 1/2, okay? Plus 1/3. Add them, flip it, it's 0.91. Why is that not right? Oh, maybe it is. 1.2, sorry. Okay, 1/2 plus 1/3 is 5/6. Flip it, it becomes 6/5, 1.2. Okay, R4, 5, and 6, 10, 2, 5. Add that, flip it. The R456 has an equivalent resistance of 1.25 ohms, 1/10 plus 1/2 plus 1/5, and then flip it. Okay, notice 1.25, that's less than the smallest resistor, which is 2 ohms. if you ended up with 2.5 or 7.3, whatever, you should know to double check, go back and check your math. Where'd you go wrong? Okay, so now I have all my resistors in series. Okay, and I could take it one step further, which makes sense. Okay, give me a sec. Okay, because all three of these resistors are in series, so I can again reduce them down to just one resistor. That's R1, 2, 3, 4, 5, 6, hooked up to my 12-volt battery. Okay, and again, I kind of like made a new entry here. Okay, so let's add that in, 1, 2, 3, 4, 5, 6, which is get R1 plus R12 plus R3 plus R4, 5, and 6. So if I add the 7.55 plus the 1.2 plus the 1.25, I find I have a 10 ohm resistor, which is 1, 2, 3, 4, 5, 6. And now I'm down to effectively where I can solve it, because this voltage, okay, the voltage of this one resistor is the voltage of my battery, which is 12. Okay, and now that I've gotten down this far, everything is working through this table, okay, because now I have V equals IR. Okay, and so once I have 12, I know delta V equals IR tells me my current is 1.2 amps. Okay, and my current for R1, 2, 3, 4, 5, 6, because I got 1, 2, 3, 4, 5, 6 from the series resistor, and resistors in series have the same current. Okay, so I automatically know that this is 1.2, this is 1.2, and this is 1.2. Okay, because they were in series. Okay, now again, I have delta V equals IR because I have two values in a row. Okay, so doing this, 1.2 times 7.55 tells me this is 9.06. This is 1.44. And this is 1.5. Okay, and again, notice if I added these up, okay, R12, R3, R4, 5, and 6. 9.06 plus 1.44 plus 1.5 adds up to the 12 of the battery. So that's another double check that you can do to make sure you're still on the right track. Okay. Still have a lot of empty squares. I have 10 empty squares. But guess what? R12. How did I get R12? Because R1 and R2 were in parallel. Okay, so R1 and R2 must have the same voltage as R12. So 1.44 and 1.44. Okay, again, delta V equals IR tells me this is 0.67, no, 0.72. And 1.44 divided by 3 is 0.48. Okay, so I have my voltage for this one. Why is this up 2 here? Okay, R4, 5, and 6, how did I get them? Okay, I got 4, 5, and 6 because they were in parallel with R4, 5, 6. So again, they have the same voltage as 4, 5, and 6. So I fill that out, 1.5, 1.5, 1.5. And I do V equals IR to get them, 0.15, 0.75, 0.3. Okay, so now my table is completely filled out, and I have all the values that I would ever need. If I need power, I can do V times I, okay, or V squared over R or I squared R, whichever one you like. Okay, so that's the process we need to go through, okay? I highly recommend setting up this table. Some other teachers teach it a different way, without a table. Whichever way you choose, okay, the hardest part about this thing is being organized. Okay, a lot of people will say, hey, I don't need to redraw these pictures like I did here. Okay, those are the people who are the least organized. And those are the people who will get a lot of things wrong because they're not organized about it. Okay? The table helps you in terms of organization. I recommend it. If you choose another method, be really, really clear with your thing. Okay? With whatever method you choose. And this, I've been recording, hopefully, this lecture. I will put this online so you can see this methodology about how to go through the process. I'll put that online in Google Classroom. And the homework actually doesn't focus too much on this just yet. Okay, I want you to get some more practice with resistors in parallel. First, doing equivalent resistances and recognizing which one do I do first, series or parallel. Okay, and then the next homework will start really doing practice problems associated with it. Any questions? I know I went through this kind of fast and it's very confusing until you actually get to practice it yourself. Okay, and just as a point of reference, okay, this resistor, this circuit has 6 resistors in it. Okay, the hard level problems are probably going to have resistor numbers in it in the order of 6 to 10 resistors. So imagine how big your table is going to get and how complicated this be if you are not organized about this approach. Okay, I really like the table for its organization. That's really the only reason. Could I do this in my head? At this point, I probably could. But only because I've done hundreds of these problems. Okay, you know, a whole bunch when I was at MIT studying to be an electrical engineer, and then a whole bunch because I teach this thing every year for the past 8 years to so many different classes. Okay, so learn from my mistakes is kind of what I'm suggesting. And I am not the most organized person. If anybody has ever seen my office, you would know that. Okay, good?